Welcome back to the deep dive.
Yeah.
We love unpacking tech here, getting into the real details. And today, we'll picture this. You've got this amazing new 4K projector, maybe for your home theater, or you're setting up screens in a big conference room. But the catch, your Blu-ray player, your media server, whatever, it's way over there, across the room, maybe even in a different closet, hundreds of feet away. So you grab a standard HDMI cable thinking, yeah, this'll do it. But then, bam, you hit that distance limit. Those cables, they get bulky, signal quality drops off a cliff after a certain length, and suddenly your dream setup is just, well, a mess of boosters, repeaters, headaches.
It happens all the time. That frustration is really common. Trying to push high-def signals over distance with standard HDMI is just asking for trouble.
Yeah, I was talking to a friend. He just finished his basement theater, projector up front, all the gear in a rack in the back room, tried a long HDMI, that's some cheaper extenders, signal drops, fuzzy picture. It really highlighted how big this problem is. And that's exactly where today's topic, HDBaseT technology, comes in. We're going deep on HDBaseT, and specifically, we're looking at one piece of kit that shows it off, the WolfPackGold 4K 30Hz HDMI receiver from HDTV Supply.
Right, so our mission today is basically to peel back the layers on HDBaseT. What is it really? How does this WolfPack receiver actually work? And, why should you care? Why is it such a game changer for sending uncompressed audio and video a long way? We're digging right into the product specs, the details provided, so you get the real story.
Okay, let's unpack that then. The core problem with standard HDMI cables. It's the length limit, right?
Yeah.
Before the signal just degrades. So what's the fundamental issue HDBaseT is trying to solve here, and how does it pull it off? It seems kind of like magic.
It does feel a bit like magic, but it's really clever engineering. The main challenge, is maintaining that signal integrity, especially for bandwidth-hungry stuff like 4K video over long runs. HDMI just wasn't designed for, say, 100 feet, 200 feet reliably, especially at high resolutions. HDBaseT is different. It uses standard network cables, Cat-T6 or Cat-T7 Ethernet cables, the same kind you might already have for your internet.
Wait, so the same cable I plug my computer into?
Pretty much, yeah. Cat-6 are better, ideally, and it cleverly bundles everything video, audio, control signals, even power onto that single cable.
Okay, so taking all that HDMI complexity and just simplifying it onto one common network cable. That's smart, especially since, like you said, a lot of places are already wired with Ethernet. Makes the installation sound way easier.
Definitely simpler. And here's the really cool part. What sets HDBaseT apart? It's designed for no compression, no losses, and no latency. We're talking tiny latency figures, like less than 7 microseconds over 330 feet. That's 0.0000007 seconds. Go shorter, maybe 100 feet, and it drops to like 3 microseconds.
It's essentially instantaneous. You can't perceive that delay.
Instantaneous. Okay, that's a strong word. Not just getting the signal there, but getting the there now. So how does that no latency actually benefit you, the listener, in the real world? Where would you really notice it?
Think about big places. Churches, auditoriums, maybe a sports bar with screens everywhere, or even pro video editing setups. If you got a speaker at a podium and screens hundreds of feet away, that near zero latency means their lips are perfectly in sync with the video. No jarring delay.
The lip sync issue, that drives me crazy. Exactly, it kills the immersion. But HDBaseT avoids that. It's also crucial for interactive stuff like touchscreens, or even if you're a gamer extending your rig to a projector. Your actions are reflected immediately. Super responsive. It's really optimized for video where timing matters.
Right, I get that. For live events or anything interactive, that precision is key. But it sounds like HDBaseT is doing more than just carrying the signal. You mentioned power and maybe future-proofing.
Yeah, absolutely. It's more than just a video pipe. It handles that uncompressed HD content, sure. But it can also deliver up to 100 watts of power over that same CAT cable. That's the power over cable, or POC feature.
Okay, POC, what does it mean practically?
It means simpler installs. You might only need a power outlet at one end, either where the signal starts or where it ends. Super handy if you're mounting a display somewhere without easy power access. And yes, future-proofing is a big part of its design. The underlying tech has the bandwidth to handle resolutions potentially double what's common today. So future 2K, 4K, maybe even beyond.
That's interesting. Future-proof gets thrown around a lot. How real is that here? When you say double the resolution, are we just talking 8K, or is it more about, like, better color or faster refresh rates too?
That's a great question. And yeah, it's more comprehensive. It definitely includes support for things like 8K as that becomes more standard. But it's also about handling increased color depth, think smoother gradients, more realistic images with 12-bit color or higher, and pushing higher refresh rates, even at those high resolutions like 4K 120 hertz or maybe 8K 60 hertz down the line. The key is that the cable infrastructure you put in now, good Cat 6A or Cat C7, likely won't need ripping out when the next display standard arrives. That saves huge headaches and costs later.
Okay, that makes a lot of sense for long-term planning. So we have this robust HDBaseT foundation. Let's bring it back to this specific unit, the WolfPackGold 4K 30Hz HDMI receiver. How does it use HDBaseT and what are its particular strengths?
Right. So the first thing to get straight about this WolfPackGold unit, it's a receiver only, an RX. It sits at the display end. It needs something sending the signal to it. An HD-based transmitter, or TX, like a WolfPack HD-based matrix switcher or some other compatible HD-based output device. You're building a system here, not just plugging in one box.
Got it. It's the destination side of the link.
Yeah.
Needs a partner. And when you say high performance, extending 4K is the big one. What kind of distances and resolutions are we talking about with this receiver?
It handles some pretty impressive distances, yeah. But it depends a bit on the signal. For standard 1080p with full 4.4.4 color, that's the best quality. You can go up to 330 feet, 100 meters over C/6 or CT7. If you're sending 4K at 30 hertz, also with that full 4.4.4 color, you're still looking at that same 330 feet. So high quality 4K over a good distance.
Okay, 330 feet for 4K, 30 hertz is solid. What about faster 4K, like 60 hertz?
Right, for 4K at 60 hertz, there's a slight trade-off. It supports it, but typically using 4.2.0 color sampling. That reduces the color data a bit to fit the bandwidth over distance. With 4K 60 hertz 4.2.0, the range is up to 70 meters, which is about 230 feet. Still pretty far.
And that 4.2.0 color, is that noticeable?
For most video content, movies, TV shows, honestly, probably not. For very specific computer graphics or text, maybe, but generally, it's a standard way to handle high-res, high-refresh signals over a distance. And importantly, this receiver is fully compliant with the modern standards you need. HDCP 2.2 for protected content, HDMI 2.0. It also supports HDR high dynamic range and Dolby Vision. That's crucial for getting those really vibrant colors and deep contrast, all running at 10.2 gigabits per second.
Okay, so the video side is covered, including the fancy stuff like HDR. What about sound? Does the audio keep up?
Absolutely. The audio is top-notch, too. It supports high-res formats like 7.1 DTS Master HD and Dolby True HD, so you get that full, uncompressed surround sound experience. Your audio will be just as clear and impactful as the picture. And there's also an optional 3.5mm audio output jack, which can be handy if you need to pull audio out separately at the receiver end.
Nice. And that power over cable, the POC feature we mentioned, how does that specifically work with this WolfPackGold receiver?
So if the transmitter you're using also supports POC, then yeah, you only need one power supply for the whole link. You can plug the power adapter into either the transmitter or this receiver, and the power travels over the CAT cable to the other end.
Oh, okay. So plug in the power at the rack with all the source gear.
Exactly. And then the receiver behind the TV doesn't need its own outlet. Super convenient, especially for tricky mounting locations. Less cable clutter, too.
You know, it's not just about moving the signal anymore. These systems have some smarts built in. Those features that just make life easier, you almost don't notice them until they're gone. What kind of intelligent stuff does this receiver offer?
That's a really good point. It's more than just signal transport. A key feature here is CEC, Consumer Electronic Control. Basically, it lets your TV remote talk to other HDMI devices connected through the system. Think Blu-ray players, soundbars, AV receivers, up to 10 of them. And usually it just works. No complicated programming needed.
Okay, CEC. That sounds like the dream for ditching the remote clutter. Can you give a clear example of how that works day to day?
Sure. Imagine you sit down, grab your TV remote, you hit the power button. With CEC working properly, that single button press could turn on your TV and your Blu-ray player and your AV receiver, switch the receiver to the right input. Even let you control the main volume with the TV remote.
One remote to rule them all. Finally.
Something like that. It really simplifies things. No more juggling 3 remotes just to watch something. We've all been there, right? Trying to explain the remote sequence to guests.
Oh, yeah. The remote dance.
CEC aims to end that. But there's a small catch, or something to be aware of. While most big brands support CEC, they often call it different things. LG has Simple Link, Toshiba uses CE Link, Samsung called it AnyNet Plus, and sometimes they might only guarantee it works perfectly with their own brand of devices. So, Sony might control Sony stuff best. Interoperability isn't always 100% guaranteed across all brands, all the time.
Right, so check your specific gear. Good tip. What about making sure the picture and sound settings are optimal, like the TV telling the source what it can handle?
That's where EDID pass-through comes in. EDID is Extended Display Identification Data. It's basically a digital handshake. The display tells the source device, here's what I can do, resolution, refresh rate, audio formats. The source then sends the best possible signal that the display supports. It happens automatically, ensuring you get the best quality without manual tweaking. This receiver also supports things like 36-bit deep color for smoother gradients, billions of colors, and XV color for an even wider color range. It all adds up to a richer picture.
Those are the kinds of background features that make a big difference, and I saw mention of some practical physical things too, little touches for installation.
Yeah, small things that matter. It comes with mounting clips, so you can easily tuck it away neatly behind a TV or in a rack. Keeps things tidy. And the AC adapter has a screw-on connector.
Oh, that's good. No accidental unplugging mid-movie.
Exactly. Prevents those frustrating power drops if the cable gets bumped. It shows they thought about real-world use.
Okay, so we've covered the tech, the features. What does this all mean for you, the listener, actually setting this up? Getting the installation right seems crucial to unlocking all these benefits we've talked about. What are the key do's and don'ts?
You're spot on. Installation, especially the cabling, is absolutely critical for HDBaseT. While, yes, it can work over standard SIG6, the documentation really emphasizes using Cat6a or even CT7 for the best performance and longest distances.
So don't skimp on the cable quality.
Pretty much. Using better cable ensures you get that full, no-losses performance HD basic promises. It's the foundation. And the source material gives some specific pointers. Crucial don't metations. Avoid those EZ45 connectors. They can be unreliable. Also, don't use patch panels in your HD Basic runs. While they're common in networking, each connection point in a patch panel can degrade the signal slightly or cause impedance mismatches, which is bad for HD Basic.
Right, keep the run as direct as possible.
Exactly. For best practices, always terminate your cables using the TIA-EIA 568B standard. That ensures consistency. And if you want the best protection against interference EMI, electromagnetic interference, which can cause random video flashes, use shielded 6.6 or Cat6a cable with metal RJ45 connectors.
Shielded cable, got it. Anything else?
Yeah, think about placement. Keep the cables away from things that generate electrical noise. Microwaves, mobile phones, radio equipment, even fluorescent lights or high-voltage power lines. That interference can mess with the signal, even through shielding sometimes.
Excellent practical advice. Cabling is so often overlooked, and if someone follows all that but still gets nothing, no image, what's the first simplest check?
Before you panic, check the LEDs on the receiver. Those little status lights are your first diagnostic tool. They'll tell you if it's getting power, if it has a solid HDBaseT link with the transmitter, and if it's detecting an HDMI signal coming in. Often it's a simple connection issue that LEDs will point to.
Check the blinky lights first. Yeah, always good advice. Well, we have definitely gone deep today on this WolfPackGold receiver and HDBaseT. It really feels like a powerful, elegant solution to that long-distance AV problem without all the usual compromises. For home theaters, commercial spaces, it really changes the game.
It really does. Preserving that signal integrity, zero latency, simplifying the wiring down to one SIA cable, adding smarts like CEC, it's a major step up. It takes the headache out of distributing high-quality AV, whether it's a single projector setup or a complex multi-screen installation. It just makes it work reliably.
Yeah. Leveraging that existing network cable infrastructure is just smart. And it makes you think. HDBaseT is already looking ahead, handling future formats. But technology never stands still, right? So thinking beyond HDBaseT, what could be the next big leap for sending uncompressed signals over long distances? Will future solutions keep using cables we already have, or will we need entirely new standards? Something to keep in mind as you plan your next big AV